Hi everybody. I've started or just finished looking over your report related to this problem, and it looks like you need some help. So I've decided to create this video. What I'm going to show you is the focus here is how to find an explicit pattern using data provided in a question. So don't forget, an explicit pattern is a pattern rule that uses a term number to determine a term in the pattern. In other words, you're going to be using a pattern rule to find the term value, in this case the number of rectangles, using the term number. What does that mean? Well, let me see if I can walk you through it. So to start, you were given a bunch of different figures. You needed to organize your figures based on the figure number and based on the number of rectangles in each figure. So I know they look like squares, but in the question you had they were rectangles, so let's focus on that. So first of all, you have to take the data and you have to put it into a table. So term 1 has one rectangle, so our value would be 1. Our term number is 1. In the second term, we have 1, 2, 3, 4, 5, let's call them rectangles. In the third term, you have to count them accurately. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now hopefully you're starting to recognize that there's a pattern. The pattern that you should recognize is that we start with one rectangle, then add 4 more rectangles around it in the next term. Afterwards, we add 1 rectangle on each diagonal arm for each consecutive term. I know the words sound interesting and some of you may not understand them, but if you read them carefully and try and process exactly what's been written, it'll make sense to you. So we start with 1 rectangle. Let's pretend that's a rectangle. We add 4 around it for the next term. Then, on the next term, we've got this already. You add 1 rectangle on each diagonal arm. Now these are arms radiating from the middle, so diagonal arms. In the next one, you add another one on each arm. That's one way of interpreting the pattern. Excuse me, another thing you should see is we're going to start looking for a common difference. What does common difference mean? Common difference describes the pattern amidst the term values. So if you look at the term values, they're changing 1 to 5 to 9. Well, the common difference that's recognized there is a common difference of 4. Now the common difference of 4 means that we're adding 4 over and over again. 1 plus 4 is 5, 5 plus 4 is 9, 9 plus 4 is 13, etc. So you can even add the 4th term to your table. It would be 4, would be the 4th term number, and then there's 13 rectangles. If you were to count, you would find that. Now the hard part though is, for the 50th term, well, how do we find out how many rectangles that will be? We could draw it, it would take us forever. Or we can use something called an explicit pattern rule. Now, if you want to visualize what an explicit pattern rule is all about, think of this input-output machine below. Basically what you have to do is, you have to consider, if I take my term and I plug my term into the input-output machine, I take my term number, put it in, whatever I do to the term number is going to come out, and I'm going to get my number of rectangles, or my term value. So that's the way the input-output machine works. And essentially, what operations can you perform to the term number to find the corresponding term value? So, what do? Well, let's have a look. The first thing I want you to remember is the common difference is add 4 each time. That's important because we can use this information when we're trying to build our explicit pattern rule. Another thing I want you to look at is right here. Let me put that back inside here. Now, what I'm asking you to do is I want you to look at the common difference and then look at the first term value. And we're going to use this comparison to help us. And I want you to answer the following question. What is the difference? What's the difference between the first term value and the common difference of plus 4? What's the difference between the first term value and the common difference of plus 4? Well, 4 minus 1, the difference between the two is 3. That's important. That 3 is really important. So we've got a 4 in the common difference. We've got a 3, which is the difference between the common difference and the first term value. And we can use those numbers when we're creating our explicit pattern rule. Why? Well, we're taking patterns from the chart that we've made, from the t-chart. And we're going to use those parts in the creation of our explicit pattern rule. And when you create an explicit pattern rule, you need to do the following. Again, we're trying to find out which operation would run this input-output machine. So we're going to try and find how we can use our term number to equal the number of rectangles, or the term value. So term number we have to do something to the term number to give us our term value. What can we do to our term number so that whatever operation we do equals the number of rectangles? Well, let's look. 1 to 1. Well, according to the first term, we don't do anything. If we leave it as it is, it equals 1. But the problem is, if you do nothing to the second term, it doesn't work. So that kind of pattern that you're thinking of won't work. We have to do some type of an operation to the first term. And it should involve the numbers that we've come up with. So we have 4 and we have 3. Those are two important numbers. So what can we do with the 4? What can we do with the 3? Well, consider the common difference. Now the common difference means that we're adding 4 to each consecutive term value to get the next consecutive term value. So what that means is it's similar to multiple addition. And then when we involve multiple addition, another way of explaining multiple addition is multiplication. So if we take our common difference and apply it to our term number, we get 4 times term number equals number of rectangles, or the term value. Does this work? Well, logically, no. Look at the first term number. 4 times, if we take the first term number and put it in here, we get 4 times 1. And 4 times 1 equals how much? 4. And that's not equal to 1, so that doesn't work. But if it doesn't work, what can we do? We can add more to our equation, or add more to our explicit pattern rule. How do we do it? Well, let me clean this up a bit. I'm going to put the 1 back over here. 4 times the term number. What do we get when we do that for the first term? We get 4. How is 4 different than 1? Because we're trying to, again, take our term number, plug it into our input-output machine, and get our number of rectangles. Well, if we have 4, how do we change it into 1? Well, could we add to it or subtract? 4 is bigger than 1, so we would logically subtract. How many would we subtract to get 1? 3. Where did we get 3 from? 3 was the difference between the first term value and the common difference, remember? Where did this 4 multiplied by come from? Well, that was the common difference. That was repeated addition over and over again. So don't forget, these numbers I'm not taking out of thin air. I'm actually getting them from my table of values. So I've got 4 times the term number minus 3 equals the number of rectangles. or the term value. Is this going to work? I have no idea. How do I check it? Well, I have to do 3 proofs. And in order to calculate 3 proofs, I use this equation, the one that I just created, and I have to test it to see if this is going to work. In order to test it, I need to take each of my terms, and I recommend using the first 3 because they're the easiest ones for counting, so you don't make mistakes. So if I take my first term, I'm going to use the same equation and test to see whether or not my input-output machine is going to work. So the number of rectangles, you know what, why don't I just call it the term value from now on, because you can see that already in the circled equation. So term value equals 4 multiplied by the term number minus 3. That's the same equation that I wrote down above. So if I'm going to use this equation, I have to prove that it's going to work. And in order for me to prove that it's going to work, I need to test it on the first 3 terms. So I'm going to test it on the first one. So for the first term, I hope you're paying close attention to this. So I'm going to call this term 1, because term 1's picture is right here. In term 1, there was only a value of 1. So I can test to see if that's actually going to work below. Term value, keep my equal signs lined up, equals 4 times, well, how many are there in the, how many values are, what is the value for term 1? 1 minus 3. What I've done right now is called substitution. I've substituted the term number into the equation. So I no longer have the words, but I've got how much the term value actually represents for the first term. So 4 times 1 minus 3. Hi there, just to recap, I had to complete my 3 proofs. And in order for me to complete my 3 proofs, I have to calculate them, and I have to check to make sure that my equation is actually going to work. So I've not done my first proof yet, but I've started. I've finished my substitution. After I've done my substitution, then I need to follow something called bedmeth. Now basically what that means is I have to identify which operation to do first. Now for our intents and purposes for this year, all that means is if you see more than one operation in a sentence, in a number sentence, do the multiplication and the division first, and then do the addition and subtraction. So for this question, we would simply write it this way. 4 times 1 equals 4. So we do the 4 times 1 first, and then we leave the subtract 3. For the next line, then we finish the calculation. So you do it one step at a time, making sure that you line up your equal signs, and making sure that you don't try and do more than one operation per line, or you're going to get confused. Now what does this prove? Well, if we go back up to our table, we said term 1 has 1 rectangle in it. If we look at our proof using our equation, term value equals 4 times the term number minus 3, if we put in the correct term number, we've got the correct value. Let's try it again. So we're going to take the same equation for the second term, and then we're going to test it to see if it works. Equals 4 times, well, what's the term number for the second term? 2 minus 3. Again, just to be sure that you don't get this mixed up, this is term 2. This is the second proof for term 2. And then if we finish the calculation, equals 4 times 2 is 8 minus 3, which equals 5. Okay, so what does this mean? We need to go back to our table of values, or we can look to the shape itself. Do we have 5 rectangles in our shape? Is the term value equal to 5? And if we use our equation to find term value, when we put in the term number. Term number is 2, we get 5 as our answer. Term number is 2, we get 5 as our answer. The equations work twice. Test it one more time for the third, and if it works, then we can use our equation to help us find how many rectangles are in the 50th term number. So for the third one, I'm just going to try and clean this up a little bit so I can run the test for the third one. The third one is this shape right here. So again, term value, start with the general equation that you're testing, equals 4 times the term number. So it equals 4 times the term number, it's the third one now, minus 3. And that equals 4 times 3, which is 12, minus 3. And that equals 9. Still don't know if I'm right, but I think I'm getting close because the first two were correct, meaning I've got my hopes up, this might work. So if I count again, 1, 2, 3, 4, 5, 6, 7, 8, 9, I've got 9 rectangles as my term value. I've attempted my equation using my term number, which was 3, and I've got 9 for my term value. Term value equals that term value is on the left side of the equation, 9 is on the right, so term value equals 9 for the third term. That matches. Well, I've done 3 proofs, all 3 work, so the equation is correct. So I write, therefore, I can calculate, or you don't even have to use a pronoun, to calculate the number of rectangles per term, simply multiply the term number by 4 and subtract 3. So basically all I've done is I've taken my equation and put it into a sentence. And that's the conclusion. The last step is, well, how do I find the 50th term value? Well, to find the 50th term value, term 50, I can use my equation very simply. I take term 50 and I plug it into where it says term 50. So it equals 4. I substitute it, times 50 minus 3. Do the multiplication first, equals, make sure you show your work, you're going to find that it's going to end up being 200 minus 3. And that equals 197. Don't forget to run a double check on your calculation. So if you do 4 times 50 to get 200, double check by doing 200 divided by 4 and you should get 50. Also do a double check of your subtraction. 200 minus 3 is 197. Do the opposite operation, 197 plus 3, and you should get 200. By running your double checks in your calculation, you can guarantee that you're correct. In your final statement, therefore, there are 197 rectangles in the 50th